Okay, in part 3 of chapter 5, we're going to talk about a fictitious force. In the previous segment, we talked about centripetal acceleration. Now we're going to talk about what people call centrifugal acceleration. And this is actually a fictitious force. It's not a force at all. So let's think about what you experience when you're in your car. All right, you're in your car and you go around a turn. Now, from your perspective in the car, you feel like, hey, something's pushing me, I'm going in a turn this way, right? So something's pushing me over this direction against the car door. Well, that's actually not true, right? That's actually not true. So remember Newton's first law. A body in motion will continue in motion unless acted upon by an external force. So what your body is trying to do is go straight, right? That's what your body wants to do. Your body wants to just go straight down the road. And so the car pushes against you, right, to make you go around the curve, just like the tires are being pushed on by the road to make the tires go around the road, around the curve. You're being pushed on by the car to make you go around the curve. Now what you're experiencing and calling this fictitious force, the centrifugal acceleration, is the equal and opposite reaction, right? Your car is pushing on you. You are pushing on your car. And what you're calling centrifugal force is nothing other than the force of your body pushing on the car as your body attempts to go straight down the road. Where do we use this? Well, we use it in something we call a centrifuge, right? And it's got the force name built right into it, except it doesn't exist, right? Well, centrifuges exist, but centrifugal force doesn't. Centripetal force does. So what's happening? Well, these little particles in your centrifuge are minding their own business when you start spinning them around in a circle. Well, when you're spinning them around in a circle, what do they want to do? They want to keep going in a straight line. They always want to go in a straight line. You get them going, they want to go in a straight line. The only reason they don't is the centrifuge pushes against them to force them to go around in a circle. And as it does that, right? As it does that, since, F equals ma and all of that stuff, mass gets involved there, right? Mass, as it does that, the heavier stuff ends up at the bottom of the tube, right? Because of all the forces involved, the heavier stuff ends up at the bottom of the tube, and the lighter stuff ends up at the top. Right? Yet there is no centrifugal force after which your centrifuge is named. Another little bit of fiction, right? And this is because this is Coriolis force, right? The force that makes hurricanes go turn in a circle, the force that makes a ball curve when you throw it really far. This is something that the British Navy a long time ago, was an Admiralty secret, that when you fire a cannon on the ocean, depending on where you are, depending on which direction you're firing it, the cannonball curves in the air. Now this isn't like a curveball in baseball where it's actually the spin of the ball and the interaction with the threads and the surface of the ball with air that makes it curve. This is a different thing altogether. So when you fire off this cannonball and you're on the ship, on the high seas, you fire off this cannonball. Well, what's the Earth doing while the ball is in the air? Once you've fired it off, all right, it's no longer interacting with the Earth other than gravity, and the Earth is spinning. Right? Just like here, if I'm at this point on a merry-go-round and I throw a ball this direction, if I'm outside the merry-go-round, i.e. if I'm not in the spinning reference frame, but I'm in a still reference frame, I see the ball just go in a straight line, right? But if I'm on the merry-go-round and I throw the ball. I see the ball curve back against the direction the merry-go-round is rotating. And that's really just an illusion in some sense because I'm in a rotating frame, right? The ball is moving along happily in a straight line. Meanwhile, my position is changing. And because my position is changing, I see it curve with respect to the rotating reference frame I'm in. So another fictitious force, Coriolis force, centrifugal force. This is just really the fact that particles like to go in straight lines and you're forcing them not to, and so their force, because of their own inertia, right, their inertial force pushes against the centrifuge and the centrifuge pushes back. And here Coriolis force, we're just in a rotating frame. As we rotate, it looks like things that are going straight curve. All right, that's it for this segment of Chapter 5. Next segment, we start talking about gravity.